Welcome back, fam. This is Mr. James, the decomposer and the synthesizer of math and science tutor. Guys, if you're not okay, if you're not good, if you're not well, as I always say, do what? Take one day at a time. And do not forget to invite God in all that you do. Do not forget to pray, okay? It's very much important, guys. Be grateful all the time. Be grateful for the doors that God has closed, for the doors that God has also opened in your life, okay? Something's gonna come up for you, okay? Always trust God in all that you do as well. Stay blessed, stay tuned. Okay, today I would like us to focus on chemistry. We are given this problem. Usually these are the type of problems that the grade 10s and 11 usually faces, study exams and tests. And in grade 12, no one is going to teach you this. You just have to know it because these are the type of questions that comes on instant-based reactions. You come across this in grade 12, okay? But grade 10, 11, you need to make sure that you master these guys, all right? Now, check it out. This falls under the quantitative aspects of chemical change and stoichiometric calculations for grade 11, okay? So now, you're given this chemical equation here, guys. You have K, which is your potassium, you have your Cl, which is your chlorine, you have your O, which is known as your oxygen. Okay, so we had to make a balance. I mean, it's not really balanced. I'm not even sure. We're still gonna check it out. Get what I'm saying? So you have a chemical equation here. So we are gonna check if it's balanced or not. Okay. So they're saying potassium chlorate. Okay, this is potassium chlorate, guys. Potassium chlorate. Okay. Remember, whenever you see the O3 is basically the ending name of the oxygen, you usually use 8, like, right, which is ATE, right? And then whenever it's having like your NO3 is this guy. Whenever you're having your SO4 is called sulfate, which we make use of that. Whenever you're having CO3, carbonate, okay? So you need to know all those polyatomic ions whenever they are combined with other elements, all right? That group, those, you know, they have common names, chemical names. So you need to know all those monoatomic ions and polyatomic ions. Study those things, memorize them, because imagine you're given this type of a problem, you don't even know what is chlorate. Okay, you're gonna focus on this guy. You get it? So it's important to know those things. It's my advice, guys, okay? If you guys don't know how to get them, I'm gonna make sure that I share them so that you guys can check them out, alright? Good. Okay, so let's continue. So now I have potassium chlorate, which you can see now, whenever you see a product, it's like a product, and then now you have to see reactants on the, usually we expect reactants to be on the left. I mean, we expect the reactants to be on the right, the product on the left. So when you see the product on the right and then the reactants on the left, you should know that that's a decomposition reaction. Let me say this again. If you see the reactants on the right, here, this side, this is my right against, like, okay. If you see your reactants this side, which is, you know, using my hands, it's gonna be my left hand side, and then your products on the right, then you should know that that is a synthesized reaction or forming reaction. Whenever the reactants are this side but the product is on the other side, it's a forming reaction or a synthesis reaction, right? Whenever it's the opposite, the product is this side but the reactants are actually on the other side, then we're talking about decomposition reaction, okay? So that is the difference between the two. Fine, if you want to identify them, ne? All right, good. So that's what we're given. Now we have potassium chloride. Basically, we're decomposing what you call your potassium chloride, potassium chlorate into potassium chloride, which is our salt and our oxygen gas there. All right. So now we're given that the mass of oxygen, no. We need to calculate. Okay. Yeah. We need to calculate the mass of oxygen when it's released. We need to calculate the mass of oxygen if it's released when the 29.4 gram of potassium chlorate is heated and completely decomposed. So we need to find the mass of oxygen. The question is asking us to find the what? The mass. We need to find the mass of oxygen. All right. When what? when the 29.4 gram of potassium chlorate, what is the potassium chlorate? This guy. So I'm given the mass of potassium chlorate, this guy, okay, when it's heated and completely decomposed. So they had to heat it up and making sure that it becomes, to decompose is to break, you know, is to break things, or a substance or a chemical or whatever bond into pieces, into different parts. So you can see they had to decompose this guy into this. So these are the parts, reactants, that were used to form this guy. Now when we want to break it down, we are decomposing that thing. Okay, awesome. Now let's see what we can do. All right, so before you have to answer this guy here, you need to firstly check if the equation is really balanced, because believe me, when you have to do the calculations here, you have to make sure that this guy is balanced. All right, so sometimes they'll give you a chemical equation when it's if it's balanced, they'll give you when it's balanced. Sometimes they'll give you when it's not balanced. So it's a must for you to always check. Okay, nobody's gonna tell you that. Whether you're in grade 11, grade 12, grade 10, still gotta know that. Okay, so now I need to see how many potassiums do I have on this side. I have one, you see, one, here, one. Just because of you don't see any number doesn't mean that it's zero. No. It's just one. There is one potassium. It's balanced. Chlorine, one. Then I have 3 oxygens this side. I have 2 this side. Okay. So yeah, this is where things could get a little bit tricky for you, because you don't know what to do. But let me tell you, since we have more and you have less, rather use the number that is more on this guy. Okay. So this is my point. You put the 3 here. Okay. Because of their more oxygens, it has the upper hand on other weights. In other weights. So now you have 3 times 2 becomes your 6. So meaning we have 6 oxygen atoms this side. We have 6. 3 times 2 meaning this 2 means that we have 2 oxygens. So when it's 3 times 2 meaning we're having 6 oxygen atoms on this side. How can we make this side so that they can also be the same? There are 3. So for me to can make it 6, what are the factors of 6? 1 and 6, 2 and 3. So I'm going to have to put 2 here. Look, 2 times 3 is also going to give me 6. So the oxygen atoms are now balanced. But since we had to put 2 here, it had to affect the potassium and the chlorine. So now we have 2 potassium, 2 chlorine. So what must we do? We have to balance on the other side as well. 2 potassium, 2 chlorine. As you can see now, the equation is fully balanced because 2 chlorine, 2 potassium, 2 chlorine, 2 chlorine. 6 oxygens. Then now you can now come to a part whereby you must do these guys here. See these guys here? Yeah. But let me show you guys, okay? Alright. So now they are saying we need to find the mass of oxygen. This guy. Let's find that mass, okay? So we are given the mass of what? Potassium chlorate. So remember the formula, which is given as N equals to M over that. So the number of moles equals to the number of moles equals to mass over the molar mass, right? So what is my mass? My mass is going to be 29.4 gram. Of whom? What is the molar mass? So I need to find the molar mass of potassium chlorate. Find the molar mass of potassium chlorate. Okay, so potassium is basically about 39.09, which is, I think is 0.89, which is, okay, something like that. Yeah, we can just make it like this, 39.0, and then you have your chlorine, which is about 35.5, is it 4.5? I think it's 4, I think it's like 4.5, which you can just make it 5, it's fine. But for you guys, you can just make, some periodic tables are different. So they are like 2 decimal places, and in chemistry, we don't usually make use of decimal places. We make use of what you call significant figures, all right? But it's cool, and then your oxygen is basically like your 60. I can just say 0.0 grams per mole. So this is grams per mole. Okay. So now let's find the molar mass. So we need to combine these guys. Here you can see I have 1, 1, 3. So here meaning when it comes to oxygen, let me just show you how to do this thing. Okay, let me just show you. So this is what you must do. So your molar mass is basically going to be 39.4 plus your 35.5 plus 16 times 3. Okay, why do we multiply the 3 by 16? There are 3 oxygen atoms. Okay, so each and every oxygen must, you get it, right? So 3 oxygen atoms times those times that molar mass of that oxygen atom, or those oxygen atoms. So that's the reason why we have to multiply 16 by 3, is because of the 3 oxygen atoms. Okay, cool. Then from there we can get the final answer of the molar mass. Let's try to do the calculations and see quickly. So I have 39.0 plus 35.5 plus 16 times 3, and we get there you go. So this is our molar mass. Our molar mass is basically 122.5 grams per mole. Okay, so remember the molar mass is measured as grams per mole. The mass is grams. The number of moles is basically just mole. Okay, so now we need to find the number of moles. Okay, because let me tell you something. The thing is that people are not aware that you can never be able to find the mass of oxygen if you don't have the number of moles. Because for you to can get that mass of oxygen, you must have the number of moles. Okay, so that's why it's important that we had to make use of the mass of potassium chlorate so that we can find the number of moles. And then from there, there's another step that we must do, which I'm going to show you, so that it can help us to find the number of moles, which we're going to use, and I believe that will help us to find the mass of oxygen, which don't worry about it. Okay, from now on, after learning from this video, I believe you're going to be able to tackle each and every problem that might be related to this type of questions. Okay, so now let's see. The number of moles now, I think we're going to have 29.4 divided by 122.5, and then our answer is 0.24 mole. Okay, now someone might say, but how did you end up getting a mole? Remember, grams and grams will cancel out, and then since it's negative, according to the laws of exponents, you make it positive, it goes on top, and then that's when you're going to get the unit as your positive mole. Okay, awesome guys. Right, so now we have the number of moles, we are sorted. Now let's try to erase so that we can have enough space. Right. So now I want you guys to see something. So we are done calculating the number of moles of this guy, potassium chlorate. Now we need to check something called the mole ratio. We need to check the mole ratio, guys. Okay. The mole ratio is basically, we're making use of the coefficients of the chemical elements that we see here. So we have 2:2:3. Understand? So we need to use the mole ratio of what we are given and what we are looking for. So what am I given? I'm given this guy. What am I looking for? This guy. So the mole ratio is basically going to be your K potassium chlorate is to your oxygen gas, which I believe this is the same as 2:3. That's what happens, 2:3. Okay, so now we need to do what now? Right now, we need to use the mole ratio of 2:3 to find the number of moles of oxygen. Okay, so someone might say, sir, or Mr. Decomposer, if ever it was 2:2, what was going to happen? Okay, let me tell you something. If it happens that the mole ratio was 2:2, here it was 2. Basically, whenever they have the same mole ratio, it means that they will also have the same number of moles. Alright. Even if it was 1:1, 3:3, as long as the mole ratio is the same, they will have the same number of moles. So it means the same number of moles, which is 0.24 of this guy, they will also be the same number of moles of your oxygen. Okay? But since right now they are not the same, what do we do? Okay, so this is what you're going to do. So let's try to find the number of moles of that. So now we are going to say, since I'm given the number of moles of potassium chlorate as 0.24, then you multiply the number of moles by 3, you divide by 2. Okay, so I'm going to say number of moles of oxygen gas is going to be 3 times 0.24 mole, all divided by 2. Okay, that's what you do. you always multiply. If it was 2:1, let me show you. If it was 2:1, you would say 1 times the number of moles you got, divide by 2. That's what you always do. Okay? Sure. I know some people want me to use that method of 2:1, and then I put x, and then I put the 0.24. You know that method basically is going to be like this: 0.24, and then here is going to be x, because you're looking for the number of moles of oxygen here. So it's going to be 2 times x. It's like a cross multiplication. So you can also make use of that method. It's going to help you. It's not a problem. All right. Then from there, the number of moles of oxygen gas. So we're going to say 3 times 0.24. Which gives us 0.72 divided by 2, and then we're going to get 0.36 mole. So now the number of moles of your oxygen gas is 0.36 mole. So we are now sorted. We found the number of moles of oxygen gas. Okay, can they help me to find the mass of oxygen? Definitely yes. Why? Because the formula tells me that if I have the number of moles and I have the molar mass of oxygen gas, then I can definitely find who? The mass. Can we do that? Yes. Let's do so. Right. Okay, so we're going to have N equals to the mass over the molar mass. My number of moles is going to be 0.36 mole equals to the mass. I don't know you, I'm looking for you. Who's my molar mass? We're looking for oxygen, right? So the molar mass of oxygen is your 60, right? So since we have 2 oxygen atoms there, you're gonna say 16 times 2, okay? Which I believe is gonna give us like 32. So I believe we're gonna have 32 grams per mole. Someone might say, am I allowed to use the 3? No, when you're doing the molar mass, don't use the 3, because the 3, we usually use it when you're dealing with the mole ratio. So please don't do that mistake, okay? Thank you. Then from there, let's cross multiply these two guys. So I'm looking for m, so I need to cross multiply. Remember, the goal is to get rid of the denominator, okay? Because you're having a fraction. So what do? Mathematically, you need to cross multiply both sides by the same 32 grams per mole, which will end up having the mass alone, and these two guys will multiply each other out, which will end up having 11.52 grams. Will end up having 11.52 grams. So the mass that they were looking for of oxygen that was released when the 29.4 gram potassium chlorate was heated and completely decomposed, it was found to be 11.52 grams. So therefore, the mass of oxygen is what? 11.52 grams. So I hope and believe that this video was able to assist those that were struggling to tackle this type of problem, okay? Remember, the first goal is to always make sure that you check you identify whether your chemical equation is balanced or not. Second step, you now come to the statement or the question that you are given to try to check what is it that they're looking for. For example, they say they're looking for the mass of oxygen, okay? Number one, how can I find the mass of oxygen? I must be given something that can help me to do that, right? So I found that I was given the mass of potassium chlorate, which is this guy. So if I'm given the mass, what must I do? Because I'm clueless now. No, remember the formula is this guy. Remember, this is your formula, all right? This is your formula. So you put the mass where the mass is. Find the molar mass. The molar mass, you're going to make use of your periodic table. On your periodic table, guys, you will see this thing. Okay, you will see carbon, and then you have 6, you have 12. The molar mass, do not use the 6. The 6 stands for the atomic number. Please, the 6 stands for the atomic number. And the atomic number, we say the atomic number is the number of electrons or protons in an atom. 2. This 12 stands for the atomic mass number. That's the one that we use, which is, some people call it the atomic weight or the molecular weight of an atom. Okay? So which is the one that we use as our molar mass. So that's the one that you must use here. Okay? So don't say, I'm not given the molar mass. You are given, just check your periodic table. Okay? Then you find the number of moles of this guy. From there, you can check who? Mole ratio. Then you check, because our mole ratio was basically 2:3. Then we had to say 3 times the number of moles that we got of potassium chlorate divided by this 2. And then in which we got 0.36 mole. You have the number of moles. We need who? The mass. How must I get the mass? Here's my formula. So where I see N, I put the number of moles. Where I see M, I just put M because I don't know him or I don't know her. Then on the molar mass, what must I do? Let's put the molar mass of that oxygen. Okay, since they are 2, say 16 times 2, which is basically 32. And then you do your own calculations there. And then this is going to be your final answer. Guys, please don't forget to subscribe. Don't forget to like. Don't forget to share this video with those people that you know that they really, really need this. Okay, I love you guys. Stay blessed.